Now, in this video, we are going to take up the introduction to the projections of straight lines. So, what is the projections of straight line? So, in straight lines, we will go for the projections of straight lines will be done only by using the first quadrant. So, the first and the foremost is the first condition is the line should be parallel to both HP and VP. So what does it mean? The line is above HP and in front of VP, because that is the condition what we consider for the first quadrant. The point to be the first quadrant, we will always say the point is above HP and in front of VP. Similarly, the line has to be in first quadrant only when the line is above HP and in front of VP. Now we are considering the line parallel to both HP and VP. So which is this vertical plane? This is the vertical plane what we are talking about. This is the one, the vertical plane, and this is the one which is the horizontal plane. Okay. Now we are considering the line parallel to HP. So parallel to HP means what? This is the horizontal plane, and the line is, the point A is above HP by this distance at this point, and similarly the point B is above HP by the same distance with respect to A, whatever you have. So now this will going to be the line which is in space, which is A and B. When you want to see this image, this is the line in space. When you want to see the image, from where should I look? Either I should look in the front view or it should be looked from the top view. These are the two possibilities. So, if you look from the front view, the image will going to fall on the vertical plane, not on the horizontal plane, because always the image will going to fall on a vertical plane when it is viewed perpendicular to that plane. The front view is the one which is perpendicular to the vertical plane. Therefore, the image will going to fall on the vertical plane. That is what we have shown, A dash and B dash. Okay. Similarly, if you want from the top view, if you want to see, or to the image what you will going to see in the vertical plane, will I be able to see the image which is falling on the vertical plane, or when you look from the top view? No. Why? Because the top view is aligned with the particular vertical plane, because these two are parallel. So that is the reason why you will not be able to see the image which is there in the vertical plane when you look from the top view. If you want to see the image in the vertical plane, I have to look always from the front view. Now, so when you look from the front view, you can see the distance above HP, and here the B is also above HP by the same distance. And when you look from the front view, that above HP will going to fall on the vertical plane. This is what we have shown. So both A dash and B dash are equidistant from the horizontal plane. Now the line is parallel to HP. Since it is equidistant from the horizontal plane, therefore the line is parallel to HP. Where that image will going to fall? The image will going to fall on the vertical plane, which is small A dash and B dash. Now the line is parallel to HP. Now I want to say the line is parallel to VP. How? If you look from the top view, you can see the distance in front of VP, that is A, capital A here. It is also at the same distance from the in front of VP in the top view. So where exactly that image will going to fall? Since the top view is perpendicular to the horizontal plane, obviously the image should fall on the horizontal plane. That is why you can see here small a and small b. So when you look from the top view, the two endpoints of the line capital A and capital B are equidistant from the vertical plane. Therefore, the line is parallel to HP. Since the line is parallel to HP, so you can see the true length in HP. What is the true length? True length is the actual length. What is the actual length? This is the actual length what we are talking about, A and B, which is the line in space. And this actual length is same as this length also, that is the image length, both in the front view as well as the top view. What does it mean? Suppose if this line has got 100 mm, that image small AB is also 100 mm, the image A dash B dash is also 100 mm. Therefore, the line is parallel to both HP and VP. Now, this is actually the three dimension. This is satisfying the condition, whatever it has been given here, the line is parallel to both HP and VP. But now, how can I represent this on a two-dimensional paper? For that, I will be rotating that horizontal plane by 90 degree downwards. So what happens? The image which was there on HP, that is small a, small b, capital A in bracket, capital B in bracket, and in front of VP will go below the vertical plane. Now you can see small a, small b, capital A, capital B in bracket and in front of VP and HP will go below the vertical plane. So on the vertical plane, whatever all the image is there, it will going to remain the same. So now the line is parallel to HP. How do I know that the line is parallel to HP? The two endpoints of the line, A dash and B dash, are at equidistant from the horizontal plane. Where that image will going to fall? The image will going to fall in the front view or in the vertical plane. Now, whether this line is in true length, that is A dash and B dash is in true length or not. If the A dash and B dash is parallel to HP, then you can see the true length in HP. What does it mean? Where is that parallel? If it is parallel to HP, then you are going to get the true length in HP. That is here. Okay. Now, how do I know that? If I want to find whether the top view line is in true length, then where should I look? I should look in the front view. If the front view line is parallel to XY, what is XY? XY is the intersection of the vertical plane and the horizontal plane is called XY. That means, if you see in the front view, if the line, the image line, that is A dash B dash, is parallel to the intersection of both vertical plane and HP, then that line is parallel. Since the line is parallel to XY in the front view, obviously the corresponding view in top view is in true length. That is small a and small b is in true length. So that is the reason why we have kept capital A in bracket and capital B in bracket. Now, so this is how you will be able to find the true length in the top view. Suppose if you want to find the true length in the front view. So what we did for the true length in the top view, if I want to find the true length in the top view, then I should look in the front view. If the front view line is parallel to XY line, then its corresponding top view, that is small a and small b, is in true length. So that is the reason why you have written capital A and capital B. Similarly, if you want to find the true length in the front view, where should I look? I should look in the top view. If the top view line is parallel to XY, yes, this top view line is parallel to XY. How do I know that this is parallel to XY in the top view? The two endpoints of the line, small a and small b, are equidistant from the vertical plane, that is in front of VP. Since these two points are equidistant from the vertical plane, the line is parallel to VP. Since the line is parallel to VP, its corresponding to since the line is parallel to VP, its true length is seen in VP. So that is the reason why you have capital A and capital B, the front view. In other words, if the top view line is parallel to XY, then its corresponding front view, that is A dash B dash, is in true length. So therefore, you can see capital A and capital B. So in this case, both the lines are parallel, That means both in the front view and the top view, the line is parallel to xy. Therefore, you can find the true length, that is the actual length, both in the front view and as well as in the top view. So that is the reason why you have capital A and capital B in the front view, and you also have capital A and capital B in the top view. Now, this is how actually we will going to write finally. The intersection of the xy line, the intersection of vertical plane and the horizontal plane is the xy line. So that is the one which we have shown here. That is the xy line. Then from xy line you take some distance and draw a parallel line which is parallel to xy in the front view, and you consider any distance, that is a dash and b dash. You mark those 2 points which is a dash and b dash. Similarly, from xy line you take below and draw one horizontal line and project from a dash and b dash to the top view. So these two lines will going to intersect at these 2 points, and you mark those 2 points as A and B. Now, if line is parallel to HP, where should I look for the line parallel to HP? I have to look in the VP. You can see in VP, the line is above HP. So whenever the distance is given with respect to HP, you take it in VP. Whenever the distance is given with respect to VP, you take it in HP. So now the line is parallel to HP. So that means the line is parallel to XY in the front view. Then obviously in the corresponding top view you are getting the true length. So you will have capital A and capital B in the top view. If you want the front view line to be in true length, then where should I look? I should look in the top view. If the top view line is parallel to XY, its corresponding front view, that is A dash B dash, is in true length. Therefore you can see this is capital A and capital B. So since the line is parallel to both HP and VP, so you will be able to find the true length in front view, that is A dash B dash, and also in the top view. Always you remember the true length is always represented by capital A and capital B. That is the indication. If the line capital AB is of 100 mm length, means what? The line capital AB means that AB is in true length. If the line has to be in true length, then it must be parallel to XY line in any one of the planes. So this is our final inference when you want to talk about the line parallel to both HP and VP. Thank you.